A group of mathematicians once got lost on the island of Milos in the catacombs. They wandered for days and days, contenting themselves not with food or water, but by thinking about the prime number catacombs of William Paulson. This is how they work. In order to move around the primary number catacombs, you need to be able to take your prime number and put it into binary. How do you do that? Well, you look for the largest power of 2, which is less than your number, and then you're going to subtract it. So in this case, the largest power of 2 less than 13 is 8. So I'm going to subtract that. 13 minus 8, that's going to be equal to 5. And then I'm going to repeat it. So 5 minus 4 is equal to 1. So I don't need any 2's. And so that is 13 in binary. It's 8 plus 4 plus 1. 1, 1, 0, 1. Let's do it again, this time for 103. So in this case, the largest power of 2 that is less than 103 is 64. So we take 103 minus 64, that's 39. 39 minus 32, that's minus 4, and we've got it. So 103 is equal to 64 plus 32 plus 4 plus 2 plus 1. In order to move through the prime number maze, you need to know which rooms are connected to one another. And those rooms are ones that only differ with one digit in their binary representation. So in this case, 103, you could replace that 1 with a 0, and you could end up with 71. So 71 and 103 are connected. Let's look at another possibility. 71, you could add a 1 at the start of that number, and you could end up with 199. So 71 and 199 are connected. You can change a single digit in the number. You can also add a single 1 out in front, but you can't add more than that. So for example, you can go from 23 to 7 like this because you're just changing a 1. But you cannot go the opposite direction because the 7 would require that you would add not just a 1 out in the front of the 7, but you'd need to add a 1 and a 0 out in front. So this doesn't work. You can't go from 7 to 23. So there's some of these trap doors that only open one way. You have to be very careful that you don't get stuck. You're going to start the prime number catacombs at 2, and then you have to go exploring. Here's the first little bit of the catacombs. And here, you can keep on going. So I'm giving you that hint if you want to keep on exploring. There's also some trap doors. These are one-way directions that you can get down, but you can't get back up again. So for example, you can go from 83 down to 19. That's one way. You can go from 19 down to 3. That's one way, but you can't get back up again directly. There's lots of puzzles and problems surrounding the prime number catacombs. Here's 4 of them. The first one is the easiest. The other 3 are either impossible or unsolved. So the first one might take an average class a week to solve. So by no means is it easy. But there are 2 numbers under 100 that you can get to, but you can't get out of. Now let's play a game with powers. In the prime number catacombs, you only use powers of 2 in order to translate those prime numbers into binary numbers. In this game, you're going to be using powers from a whole bunch of numbers. Good luck. So we start in level 1 with powers of 2. So here we have 2 cubed. I'm going to remove that from 37, and again, and again. And 2 to the 4th, that's going to be 16. I'm going to take that off there. 2 to the 4th again. I'm going to take that off 73. 2 cubed is 8. I'll take that off there. 2 cubed, take that off there. 2 cubed again. Well, I can't, that's going to be 8, so I can't take it off one of those. I'll take it off here. 2 cubed again. 2 to the 4th. 2 squared, I'm going to take that off there. That's 1. 2 to the 4th. 2 cubed. And 2 squared, I'll take it off there. 2 cubed, I'll take it off here. So you see the way the game works. You're all the time trying to decrease these. 2 to the 1. Oh, that's going to be 2, so I can't take it off there. 2 to the 0. Finally, I'll be able to take it off there. So I got rid of 1 of them. Good. Got rid of 2 of them. And the last one, thank goodness I finished that. Here I'm on level 4. I have to use these squares and cubes in order to solve for these ones. 2 cubed is 8. That should work. 1 cubed. That looks good. 3 cubed is 27. I'll go over here. 1 cubed. Oh, I've got 3 successive 1 cubes, so I'm going to use them, all 3 of them over here to get rid of that. So 2 squared. 8 squared is 64. So there's only one place to use that. That doesn't make any difference. 2 cubed. I'll put that in here. Okay, 4 squared. That's going to be 16. I'll put it in here. 7 squared. I'll put it over here. 4 squared is 16. And 5 squared. I've got nowhere to put either of those, so I'm going to discard them both. 0 and 1. 2 squared. Good. And 2 squared. 1 squared and 1 cubed to get rid of that one. Good. Just in time. 2 cubed. I'm going to put it here. 2 cubed again. And 1 squared. Oh, I'll put these 2 ones over here to get rid of that. 9 squared is 81. Boy, that's big. 2 cubed. There we go. So you see the way that I'm playing. Oh, 11 squared is much too big. 1 squared, 1 squared, 4 cubed. Can get that down to 3, and then got rid of another one. Yes, success.